All right, last new material for this unit, molarity and dilution. So for my people who love math, today is all math. Hopefully, I mean, we've talked about molarity before. Actually, every single time that we do a lab, the chemicals that we use, they have a concentration associated with it. It would say like 1.0 M. Did you ever know what that M stood for? It means molar, molarity. So that's telling you that that specific chemical, hydrochloric acid, is 1 molar. That's the concentration of it. Okay? Because molarity is a concentration value. Okay? Dilution, is everybody pretty familiar with what the word dilution means? Okay? And if you're not, then in a little bit you will know. Those go kind of hand in hand. Okay? In order to solve a dilution problem, you have to have molarities. Okay? So when we're talking about concentration in calculations, this first vocab word is just concentration, and not the concentration that I'm hoping that all of you are having right now while I'm teaching, but the concentration of the amount of a substance per defined space. So on the solubility curve, this was expressed in terms of grams of solute per 100 grams of solvent. So yesterday I taught my B-Day solubility, okay, and I don't remember if I mentioned this to you guys before the break, because if I'm being honest, I don't really remember. It's been a while. But I want you to think about any time you have taken a sip of like lemonade or Kool-Aid or anything, and you've taken a sip and you're like, ooh, like it feels watered down. Has anybody ever experienced that? Yes, are you saying yes? Okay. Would you think that that drink is highly concentrated or not very concentrated? Not very concentrated, right? That is what it's talking about. That is saying that you have more solvent than you do solute, right? Present. Versus you take a sip of that same Kool-Aid or lemonade and you take a sip and you're like, oh my gosh, super strong. That would mean they would be highly what? Concentrated. Which means you probably have more solute than you do solvent. Okay? So, when we talk about using solubility in math problems, we rarely express the concentration of a solution in terms of grams of solute per 100 grams of solvent. Rather, we use the concept of molarity. So, molarity, okay, is the number of moles of solute, so the number of moles of solute per liter of solution. Okay? The number of moles of solute per liter of solution. So you can see right here, I have this boxed, because this is, if you look on your formula chart, to solutions, isn't that what our unit's called? Solutions. So, molarity, capital M, because what is lowercase m? Normally what we represent for like mass, right? And actually, when you get to AP Chem, a like italicized cursive M is molality. I know, like why do they want to make things difficult? We have molarity and molality. We will not be discussing molality, but if you go on and take AP Chem, you will. But if this formula is on your chart, do you have to have it memorized? No. Okay? So it's moles of solute, and this is expressed in N because moles in a lot of formulas is expressed as N, and you will see that again when we get to gas laws, over liters of solution, right here. Okay? This next formula is basically showing you that if I were to give you a substance that is in a gram, I give you grams, can I plug grams into this? No. So this is showing that I have to take my mass and divide it by molar mass, because that's how we get moles. Okay? If I gave you a value that was in milliliters, what would I have to do? I'd have to convert it to liters. So these are your units, moles / liters or M. You have to know that. Okay? All right, so if you had 2.0 moles of potassium nitrate that is dissolved in enough water to make 1.0 liter of total solution, we would say that the concentration of the solution is 2.0 molar or 2.0 moles per liter. Or we could also say that we have a 2.0 molar solution. Molarity is a common way of expressing concentration of solutions. As you increase molarity, that means that the solution has become what? More concentrated. Very good. Okay. When we decrease molarity, that means that a solution has become. So we're actually going to use, okay, what did you say? Very good, more diluted. Okay. So Grima told me her high was she had some really good ramen. Okay. Think about ramen. If I were to add a whole bunch of water to my ramen with not a lot of seasoning, would you consider that to be diluted? Yes, right? You're diluting it. When you add more solvent, you are diluting it. That's a case for anything, right? If you add more solvent than is needed, it's diluted. It is that example that I told you about when you take a sip of something and you're like, ooh, this is watered down. It's diluted, okay? So this example right here is a really good example for, because you guys don't ever see Tillman or Miss Sapoko or myself actually make chemicals, because we always do that like either before or after school. But anytime you guys do a lab, and when you do your solutions activity on Friday, there are chemicals that we will have made. We don't ever just get, what's that noise? Oh. Hello? Hello? It's my favorite thing to do, answer phone calls. It's always better when it's parents. And they're like, what, who's this? I'm like, this is your child's teacher, currently teaching your child. Anyways, what was I saying? Oh, us making chemicals. So when we get chemicals, we order them from companies, various companies. We get them in. They are not in the concentrated state that we actually have you guys use. So when we get hydrochloric acid in, we get it in like a 6 molar or a 12 molar, which is a very strong concentration that could probably eat and melt away somebody's skin. So I'm definitely not going to let you guys use that. So what we do is we take that high concentration and we dilute it down to the concentration that you guys can use. So this right here is talking about how would you prepare 1 liter of a particular molar solution of a solute. We would use a volumetric flask. Why would we use a volumetric flask and not an Erlenmeyer flask? Anybody? Not specific. Precise. Precise. Volumetric flasks are considered precise. Remember? Same with graduated cylinders, same with burettes. So we would use a volumetric flask to prepare this. So this problem says, what we first would do is we would calculate how many grams are needed for the moles of that solute that it would be. Okay? Because we're just given a value and we have to figure out how many grams of that we need. We would mass out that many grams of the solute on a balance. Add that amount of solute you massed out to a 1 liter volumetric flask or whatever size you need. We would then add distilled water. Why do you think we would add distilled water and not tap water? Tap water has a bunch of minerals in it. We talked about that, remember, last class, the difference between tap water and distilled water when it came to electrolytes. So we'd add the distilled water until the bottom of the meniscus, and then we would mix it up. Okay? That is what we do for every single solution. Whether that solution is, obviously if the solution we get, hydrochloric acid, is a acid, so it's already dissolved in, it's aqueous. So obviously we wouldn't weigh that out. We would have to we'd have to use that with a graduated cylinder and then do that type of conversion. Versus copper nitrate comes in a powder that we can weigh out. So it's all dependent on what the solution is. So we're going to do an example, and this example is very helpful because next unit for our acid and base unit, you have a test for that unit, but we will be doing a titration lab where you will also have a titration lab write-up, which is an AOL also. And so this is going to help you with writing out, because you guys have never, at least in our class, had to actually write out how to perform something, okay? And when you get to college, those nice lab sheets that we give you that tells you, okay, you need this, 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 step 1, step 2, that's not what happens in college. You have to write it out, okay? So this is good practice. So this first example says how many grams, okay, of sodium hydroxide must be used to make 500 milliliters of a 2.5 molar sodium hydroxide solution, okay? So I like to come out to the side and write down what we have. We have mass, that's what we're trying to find. We have volume and molarity. What is our volume here? So Vidyu said 0.5 liters. How did he get that? He converted milliliters to liters, okay, using dimensional analysis. So 0.5 liters. And my molar concentration, bless you, is 2.5 molar. We know our formula is molarity equals moles over liters, okay? So when I plug in what I have, 2.5 equals x over 0.5. Okay? Bless you. So everybody solve this. Elisa, what'd you get? Good. So 1.25 moles. And this 1.25 is moles of what? Bless you. Sodium hydroxide. And what's the formula for sodium hydroxide? NaOH. Why is writing down the formula important here? Yeah. What? No. 2.5. This is, yeah. Why is it important that I write sodium hydroxide down correctly? Yes, Joey. Change the results how? Well, because is this my answer? That's not my answer, right? Because is the question asking for how many moles of sodium hydroxide? What's it asking for? Grams. So, again, if I have moles, why is it important that my formula is correct? Because what is my next step? What do I have to do? Molar mass. So now is it clicking why the formula is important and correct? Because would my molar mass be wrong? Yeah. So 1 mole of NaOH. What's the molar mass for sodium hydroxide? Anybody? Everybody should be calculating it because everybody has a periodic table in front of them. It's 40. Okay, everybody solve this. And yes, you do have to show dimensional analysis for this. No work, no credit. Adeline, let me know what you get. Say it again. 50 with a decimal. Okay. And then grams of NaOH. Why did we use 2 sig figs here? I agree, but why? Yes. This is 3, this is 2, so we take the smallest. Okay? Alright. that is the first part. Now it asks, how would you go about preparing this solution in the laboratory? So, what do we think our first step would be here? What's my first step to prepare this solution in the lab? Because right now, I don't have a solution. Right now, I have a gram substance of sodium hydroxide. So what would be my first step? Yes?
Weigh 50 grams of sodium hydroxide.
So I'm going to mass out 50 grams of an AOH using electronic balance. Okay? And just FYI, if I were to just have written weigh out 50 grams, you would not get any points for that. Because it's like weighing 50 grams of what? And then what am I going to use to weigh out 50 grams? Okay? What do you think my next step would be? What am I going to do with this 50 grams that I just weighed out? Yeah.
Put 500 milliliters of water into the molarity flask.
So, I have to do something before that. What do I have to do before that? What do I have to put in my volumetric flask before I add water? The what? The solute, which is what? What's the only thing that we've talked about that's a solute here? Okay, so I'm going to put 50 grams sodium hydroxide into 500 milliliter volumetric flask. Okay? Anytime, and this is not something that you guys particularly should know, but anytime you are, because sodium hydroxide, is it a base? Is it a strong or weak base? Strong. Anytime you're working with even a weak base, you always add your solute first, and then you add your solvent. Okay? Because if I were to fill, well, actually, before I tell you this, anybody want to tell me why you add the solute before you add the solvent? Yeah? Okay. Think about, and I talked about this, I don't remember if it was with you guys, we talked about whenever you have cereal, okay? Like, any normal civilized person would have cereal, put the cereal in the bowl first, and then you add the milk, right? Because cereal is a solid, and if you add the milk all the way to the top, and then you add your cereal, what's going to happen? You're not going to be able to add all of it, and then it would spill over, right? Well, if I add my water to the 500 milliliter line, and then I add my solute, is it going to go over? Yes. That is why you add your solute first. You add your solute first, and then you add your water. Okay? So my final step would be add water to line and mix. Because on every single volumetric flask, there is a line. That line is your meniscus. And that line tells you that is 500, that is 100, that is 50. Okay? Questions about this one? Nope. All right. All right. If 35.8 grams of lithium hydroxide are dissolved in enough water to make 750 milliliters of solution, what is the molar concentration, in parentheses molarity, just FYI, like on your test, I'm not going to put in parentheses molarity. You need to know that molar concentration is molarity. Molarity is a concentration value of the solution. All right, so we have mass molarity, volume. We're trying to find molarity. Our mass is 35.8 grams, and our volume is 750 milliliters. What would I have to do? Convert. When I do that, I get what? 0.750 liters. Formula is molarity equals moles over liters. Can I, with the information I have right now, plug that into my equation? No. What do I have to do first? Convert grams to moles. So 35.8 grams. Lithium hydroxide. What's my formula, Nithya, of lithium hydroxide? LiOH. Everybody needs to be calculating the molar mass of lithium hydroxide right now. Shiloh, what's the molar mass? Very good. Everybody now needs to calculate this. Now, because both of our givens are 3 sig figs, okay, whenever you solve this, okay, I want this to be 3 sig figs. Normally I tell you guys to wait till the end to round, and that's normally always the same. But because I'm going to be plugging this into my equation that's next, that also will have 3 sig figs, it will be fine. So when I solve this, Miley, what do you get? 1.49 moles. So that's my mole value. So now this value will go at the top, divided by 0.750. And Gavin, let me know what you get. 1.99 M. And again, y'all, just an FYI, just so I really make sure that you know that if you do not do a capital M, that is wrong. Okay? Questions about this one? Okay, I want you to do this next example on your own. Yes, Joey.